Hello everyone, this is Mehul Sakariya presenting to you the final year project titled Breast Cancer Detection using CNN. This project has been developed with two of my teammates Ankur, Tikoo and Adarsh Kumar Singh. So let's begin with the walkthrough of the code. We are starting with importing the necessary libraries that are required for the smooth functioning of the program. We are using libraries such as pandas, numpy, tensorflow, matplotlib and many more. Moving on to the data structure, the dataset that we are using. Our dataset consists of many histopathology images. Histopathology images are the microscopic view of cells and tissues. So our dataset is divided into number of folders of patients. Each patient folder has two subfolders 0 and 1. In the 0th folder we have images of tumors or cells that are not cancerous in nature, while in the folder titled 1 the images are of cells that are cancerous in nature. Moving on, we are here pointing to the dataset. We have almost 2,77,000 images in our dataset and almost 280 patients. As we can see, data head, the data that we have here, this is the patient ID, path of the image and target 0. 0 means it is belonging to the folder that contains all the images of benign tumor. It's exploring the data, displaying cancer tissues. This is we are looking into the images that are part of the folder that contains the cancerous tissues. These are the images that do not contain cancer. If we carefully observe here, the cancerous tissues have a purplish texture to the cells. We're setting up the directory structure for our program. In this part we are creating the data frame, the pandas data frame, for easier manipulation of the data. As you can see, the image ID and the patient ID and the target from the target means the location that we are extracting the image from. Moving onto the class distribution of images. As we can see, the number of images in the folder, the number of patches in the folders of non-cancerous part, they are a lot more than the cancerous part. So if we move on with this, the model would lean towards one side and would not generate accurate results. To counter this, we have to balance our model, we have to balance our data set. So to do that, we are taking the same number of images that are present in the cancerous part in the non-cancerous part. For the training and test purposes, the dataset, we are dividing the dataset into training, test, validation part. For testing purpose, we are only using the 10% of the dataset. Rest all is for training and validation purpose. Okay. So now we have the test size already declared. We move on to the training and validation part. We are creating two folders for training and validation, and within those folders there are subfolders benign and malignant. So we'll put all the images that there are the patches that are into these folders, and so that we can build our model on this. Setting up image generators. Image generators are basically used for image augmentation. They help us in countering overfitting issues. Coming on to the part of building the model. In this case, we are using a sequential model. So sequential model is the appropriate choice here because we have a plain stack of layers, and it is supposed to be only used when exactly one input tensor and exactly one output tensor is present. So in this model there are exactly 4 parts. First three parts are the 3 convolutional layers, followed by a max pooling layer and a dropout. Convolutional is the first layer to extract features from the input images or patches. It preserves the relationship between pixels uh, by learning image features using small squares of the input data. The convolutional layer that here takes a kernel or filter to extract the features. As we can see, we have kernel size of 3 by 3 in this model. For the purpose of activation, the activation function that we are using here is the ReLU, rectified linear activation. Moving on to the max pooling layer. A max pooling layer basically downsamples the input along its spatial dimensions such as height and width by taking maximum value over the defined window. The dropout layer, it randomly sets input units to 0 with a frequency of rate at each step during training time so as to prevent overfitting. Then the last part, the flatten layer part, it basically flattens the input for the dense layer. Coming to the training part of the model. So for compilation, the optimizer function that we are using is Adam, and optimizer basically helps us to adjust weight of edges while training. The loss function we are using is binary cross entropy, and we have decided to train our model over 20 epochs. So this is the part, and saving the model, moving on, loading the weights and generating the graphs. So as you can see, over the course of the training, the loss starts to decline as we reach the 20th epoch and accuracy increases. So our model has been built and trained, so it is ready for prediction. Prediction function that we are using here is predict underscore generator. So now the prediction is completed and we're putting the prediction into a pandas data frame. Alright, so the AUC score, the area under curve score is 94%. And moving to the confusion metrics part. Confusion metrics, as the statistics stand, true negatives are at 6634, false positives 1245, false negatives 750, and true positives 7129. After we have all these confusion metric statistics available, we can derive the classification report using the sklearn library. We can generate some important statistics such as precision, recall, F1 score. Precision can be calculated by the true positive divided by true positive plus false negative. Recall can be created by true positive plus true recall can be done by true positive divided by true positive plus false negative, and precision true positive divided by true positive plus false positive. And F1 score is the harmonic mean of both precision and recall. Thank you. That was all from my side.